So today let's talk a little bit about big data, what it is, what it's becoming, and how to deal with it. Analytics helps an organization to learn about its sales world, to learn about its product, to learn about how the world is accepting their product and how their customers are reacting. Well, of necessity, there's times when you have to do research outside of your corporation in order to get the information that you really need. You know, internal sales data is one thing, but getting an external set of data tends to give you a much more broad depth of information concerning the products that you're researching. So big data is a collection of large data sets. It tends to be unstructured data, data that you just get in pieces and parts and have to draw the correlations yourself through your analysis tools. So there's four common characteristics of all big data sets, and they are all beginning with a V: variety, veracity, volume, and velocity. So variety is, you can kind of know what variety is. It's just data on different subjects so that you can correlate those different subjects together and get a bigger picture. Veracity, it has to be true. It has to be good data. It can't be anomalous data that you get from, let's say, a bad instrument, or bad data coming from individuals or people. The volume, of course, to be big data has to be big. Okay, we get that. Velocity. You have to be able to get good data in a timely fashion. And velocity is kind of dealing with the idea that you can get good data that's pertinent to today, and not old and stale. Okay, so let's move on. So distributed computing then processes and manages algorithms across the company to analyze the data. Now, big data analytics, such as what SAP offers for their ERP system, tends to be a way to do this, as well as other big data products that are on the market. So you can create virtual versions of computing resources in order to place the data. And through virtualization, you can have various data mining tools that can be put to work with the data, specifically in large corporations that have virtual machines in their data center. Data mining is the process of analyzing, extracting the data. Data mining tools are a variety of tools like Cognos and other reporting tools that are available out on the market today. So the techniques that you use to mine the data are really techniques that classify, that estimate, that you can get affinity group data and cluster the data together. Prediction analysis is another thing. When you get enough data on a particular subject, you can begin to predict based on historical data what the future trends might be. You see that a lot when weather forecasting is such a big part of our day now. You go to a weather forecasting site and they'll tell you about what the temperature is going to be for the next 2 weeks. And these are all because of predictive analytics that they've used on some very large data sets, so that when they have certain conditions, of course, they can then extrapolate that into the future to say, well, meeting these certain conditions today and what's been leading up to that, we can predict what might or probably will happen in the future. So databases usually contain all that information in two-dimensional tables. Data warehouses, though, they can contain information that's multi-dimensional. And we'll talk about this cubing idea here in a moment, but a dimension is a particular attribute of information. In other words, an attribute is subject matter. So maybe in our weather data example, it would be temperature or precipitation. So a particular dimension would relate and drill into those pieces and parts of the information. Now, a data cube is a common term for representing multidimensional information, but a cube, has 3 dimensions to it: height, width, and length. The challenge with relating it in our minds to a data cube is that there can be 12, 13, 14 different dimensions to a data cube. And you can drill in on all of these dimensions, sometimes all at once. So cubing, yeah, keep that concept in mind. It is a piece of data in the center, but dimensions allow you to drill into that data a lot of times from more directions than what you see in a cube in particular. Now, because of our limited ability to represent that on a screen here, we have, a data analysis done in cubes here. And here we have 3 dimensions, height, width, and length. So the stores along one, the products along another, and the different promotions along the bottom. And you can drill into just the information about promotion 2 in that second piece of the video. And then you could drill into just promotion 2 and store B, for example, in the next dimension. So what it does is it allows you to then relate the data to particular dimensions, and it's not limited to just the 3. I might have product B at store 2, but store 2 has run more promotions than just those 3, and it has another dimension that may have affected sales that I might want to slice it, like the day of the week or the day of the year or month. Those types of things could affect the data in such ways. And because of that, you might have more dimensions than just the 3. So the challenge then becomes, how do you present that data to people? And this has been worked on for many, many years. And I've given you just a few examples here. Data visualization and infographics and business intelligence dashboards are just 2 examples. But those dashboards and those infographics can include a multitude of different types of presentation and data, like column charts that I show in the top picture there, bar graphs. You have stacked bar graphs and line graphs. The Meko charts that you see in the bottom right picture there on the screen, that bottom right picture allows you to see it in relationship to the size of the particular pieces of data in there. And then, of course, pie charts allow you to see size, but they're 2-dimensional. And there's scatter plots and bubble charts and bullet graphs. A lot of different ways have been presented to try to help the executives who don't necessarily want to understand the data at the data element level, but help them understand the data at a macro level so they can make, long-term decisions of strategy and so forth without having to get into the minutia of the data. So the whole point of visualization is simply, how do you get the data presented in such a way that it gets the ideas of the information rather than just the detailed data itself? So I hope this has kind of given you an idea what big data can do and the challenges with big data, in the fact that it gets so big that conceptually it's hard to present to users. So if you like the content, hit the like button, and please help us grow the channel by subscribing, and we'll hope to see you again later. Thanks.